Hi, my name is Emil Anhulik. I work with the Market Strategy and Applications section for Ixom Water Care. Many of you might have known us better as Medora Corporation or SolarBee. Medora Corporation was acquired by Ixom in February of 2020, and we are happy to be a part of the newly expanded Ixom family. Welcome to today's presentation, Active Mixing, the Unsung Hero of Water Quality. When it comes to most anything water, oftentimes the most powerful tool in the water quality toolbox is movement. Keeping the water moving and eliminating any stagnant areas can help overcome almost any impairment, from lakes to drinking water treatment through distribution to wastewater collections and treatment. Active mixing can have an important role in improving your water quality and treatment processes. This presentation will quickly explore what mixing is and how we define it, why we need it, and why active mixing wins out. From there, we'll give a quick overview of water quality and operational benefits as it pertains to certain scenarios in three different areas, those being water treatment and distribution, wastewater collections and treatment, and lakes and source water reservoirs. Lastly, we will go over some things to consider when choosing active mixing equipment. All in all, this presentation will take just about 20 minutes or so. With that, let's get to some basic mixing 101. We define mixing as an external energy source mechanism causing fluid disturbance. Simple enough idea. From there, mixing is split into two distinct categories, passive mixing and active mixing. To figure out whether a particular type of mixing is active or passive, you just have to answer two straightforward questions. Can the mixing be applied at any time? And can the mixing be applied for any length of time? If the answer to any of these questions is no, then it is considered passive mixing. On the other hand, if both answers to these questions are yes, then it can be considered as active mixing. So let's put the questions to the test and take a look at a few quick examples. Example 1, wind mixing on a lake or larger open reservoir. The wind can be a powerful mixing force on large bodies of water, and to figure out where it fits in the mixing world, let's ask the questions. Can mixing be applied at any time? No, we cannot control when the wind blows. So the next question is, can mixing be applied for any length of time? The answer is also no. We cannot control how long the wind blows either. So wind mixing is considered a passive form of mixing. Example 2, directed check valve inflow mixing in a drinking water distribution tank. So let's start with the first question. Can the mixing be applied at any time? Maybe yes. A person could argue that they can direct inflow into the tank at any time they want. The second question, can the mixing be applied for any length of time? The answer there is no. Typically, most fill cycles cannot go on forever, so inflow mixing, even with directed check valves, is also considered passive mixing. Example 3, an air-powered mixer in a wastewater basin. Question 1, can the mixing be applied at any time? Answer is yes. Question 2, can the mixing be applied for any length of time? Again, the answer is yes. Since both answers are yes, this can be considered active mixing. This method of categorization is overall pretty easy. Passive mixing is okay, but it's just okay. There are some shortcomings there. Whereas active mixing is truly the only reliable mixing strategy you can count on day in, day out, especially when you really need it. Now that we know how to identify passive versus active mixing, there is another important concept we need to understand. You see, the amount of flow in and out of a given reservoir, even if it is a high amount of flow, is not a dependable indicator of mixing. This is mostly due to a flow characteristic we know as short circuiting. So let's take a look at that. Short circuiting is the concept that water will always take the path of least resistance, and it can happen due to a combination of factors such as the position of the inflow and outflow structures in comparison to the rest of the reservoir. The water temperature of the inflow is warmer or colder than existing water in the reservoir. The chemical makeup of the incoming water is different than that of the existing water in the reservoir, and or pressure differences caused by the overall depth of the reservoir. Short circuiting acts the same in drinking water reservoirs and tanks as it does in wastewater reservoirs and basins, as it does in lakes and source water reservoirs. The basics are all the same. So let's go through some scenarios. First, we show the natural short circuiting path from inlet to outlet using an overhead profile. Water on either side of this path will not mix easily with the incoming and outgoing flow. Second, we show the temperature gradient using a depth profile. Warm water will not easily mix with cold water and vice versa. This can create short-circuited flow along the top or bottom of a reservoir. This next graphic shows how both inlet and outlet position and water column temperature differences can work together to create short-circuiting. Even though this reservoir has baffles, you can see cold water coming in will travel all the way through and out of the reservoir without ever mixing with the warm top layers. The reverse is also true. We see this a lot in wastewater. Warm water can short circuit across the top and out of the reservoir, never mixing with the colder bottom water. And this graphic here illustrates how chemical differences can also create short-circuiting scenarios. For example, water with a higher chlorine residual is heavier and will fall to the bottom. And this is also true of water with a higher salt content. It will also fall to the bottom. This graphic also shows how pressure increases in the water column, and this can lead to other short-circuiting scenarios. So to wrap up this section, defining the short-circuiting path is important for any reservoir mixing application, especially in drinking water and wastewater. Active mixing is really the only way to reliably ensure short-circuiting is disrupted, which in turn helps improve your overall treatment processes. As a little side note, even though lakes follow the same reservoir short-circuiting rules, from an application standpoint, we treat lakes a little differently in regard to the overall mixing strategy. We'll touch on that here in a little bit. All right, let's breeze through some water quality and treatment benefits that active mixing can provide. And we'll start with water treatment and distribution. Active mixing in a distribution tank or even in the clear well at the plant can provide a lot of benefits. Active mixing eliminates thermal stratification, prevents stagnation, creates a uniform water age, and it creates consistent and even disinfectant distribution throughout the tank. Active mixing can stop short-circuiting, reduce biofilm buildup, increase disinfectant contact time, and it can provide continuous THM and DBP removal. That's a lot of positives right there from something as simple as adding active mixing into the tank. And for those of you who live in places where winter's a real thing, active mixing can also help fight against ice formation. That's a super big plus, and it can keep expensive tank damage from happening. In short, active mixing capability should be a given for most every distribution tank. There are just too many upsides not to. Moving on, let's take a look at wastewater collections and treatment. Now, this is a longer section because many systems and treatment processes are just so different. We're going to start off with pump station wet well mixing. This type of application just goes to show that even in very, very small reservoirs like wet wells, active mixing can help improve the situation. Active mixing can help fight against fog, otherwise known as fats, oil, and grease. It can keep wipes and other materials from clumping and in suspension. This helps increase pump pass-through, which also keeps pumps from clogging. Active mixing can also keep hydrogen sulfide odor and corrosion at bay, and it can also reduce overall maintenance costs. Here real quick, you can see the before and after effects of active mixing. It's pretty impressive what something as simple as a little bit of active mixing can do. Next up, we're going to take a look at larger wastewater ponds and applications. Active mixing can help most any wastewater pond regardless of the type of system. Active mixing reduces short-circuiting and increases detention time. It improves BOD and TSS reduction. It increases methane transfer, facilitates better sludge digestion, and it can prolong time between dredging. Active mixing can also minimize algae-related problems and reduce or eliminate nuisance odor issues. One wastewater pond attribute that most people don't consider is surface tension. Tight surface tension is usually due to films and fats on the water surface, and it keeps a pond from exchanging gases with the atmosphere. Active mixing can help loosen the surface, which essentially allows the pond to breathe. Methane can escape and oxygen can enter, which makes the overall health and processing power of the pond just that much better. You can see that one side has no active mixing and the other side does. It is quite the difference. Again, no mixing here and active mixing here. Probably one of the biggest cost issues for partial mixed ponds and systems with aerated basins revolves around extensive energy use. On average, 45% of energy these systems consume is used just for aeration. That's a big chunk. But if a system can separate out aeration needs from mixing needs, you could save a lot of energy and in turn save a lot of money. You see, aerated basins and partial mixed wastewater ponds typically need much more aeration horsepower for mixing than they do for dissolved oxygen production. With added supplemental mixing, the aeration system can be dialed back to provide just the dissolved oxygen that is needed. Existing aerators can be left in place but run them for less hours. Energy efficient floating mixers have been proven to displace 30 to 50 horsepower of aerators used as mixers. And by doing this, you can achieve substantial energy savings with a quick payback. And the key being the payback. If it's done right, the active mixing equipment is essentially free and the energy cost savings are ongoing. That's a win-win. If you have a system with extensive aeration used for mixing purposes, you should take a good look at what a dedicated active mixing strategy can provide. So beyond energy savings, active mixing can help with other types of wastewater applications too. We'll start off real quick with activated sludge, not because of potential energy savings, which we just discussed, but because many people don't realize that the right type of active mixing can be applied to anoxic basins too without adding oxygen. And that only makes the anoxic basin function that much better. For sludge storage ponds, active mixing can provide more consistent odor control. It can even out the sludge blanket and reduce sludge mounting. Less bacteria is thrown into the air, less maintenance is required, and there are no struvite issues. For effluent storage ponds, mixing can help fight against cyanobacteria blooms, lessen or eliminate irrigation nozzle plugging, lessen or eliminate irrigation odors, reduce high horsepower to meet mixing needs, and it can help some systems comply with pH and dissolved oxygen limits. For equalization basins in front of a wastewater treatment plant, active mixing can help in a variety of ways to help provide a consistent and predictable flow of water into the plant regardless of variable flow entering the basin. By keeping the water thoroughly mixed, sand and silt withstanding, there is less settling as the water moves through the reservoir. This creates a smaller detention time for both the water and organic solids, and a more uniform and consistent influent enters the plant. A good mix also keeps any anaerobic processes from ever gaining any odor-causing momentum. Now, lastly on the wastewater front, active mixing can be used to efficiently and effectively distribute chemical. Here's a quick story where a system tested their normal boat method of applying alum in comparison to using a floating wastewater active mixer. What they found was that by using the active mixer, they achieved better phosphorus removal with less alum. So better removal, less alum. It took less personnel resources, and they found it could be done in a much more safe manner. Next on the list is active mixing in lakes and source water reservoirs. We have a little saying around the office that potable water guys don't usually talk to wastewater guys, and wastewater guys don't usually talk to potable water guys, but they all go fishing. This is probably why our lake applications tend to garner more interest from a broader audience, because the simple fact that the lake is a centerpiece for much of our summer and year-round recreation. And lakes are a little different in the mixing world. First off, their sheer size and scope alone can be a challenge. And nutrient loading is extremely variable based on a host of factors that are often unpredictable. Lake inflows generally come in colder and will sink to the bottom of a reservoir. If a lake is already stratified, wind will tend to only have a mixing effect on the top water, and even then, the wind doesn't always blow. So any active mixing strategy for lakes needs to focus on one of two parts: the top water, known as the epilimnium, or the bottom water, known as the hypolimnium. Let's take a look at top water epilimnetic circulation first. Epilimnetic circulation starts with identifying the thermocline, or point of significant stratification in the water column. If your reservoir is less than 7 to 8 feet deep, you may not find much temperature variance except for at the very bottom. For deep bodies of water, the point of significant stratification can be anywhere from 6 to 9 feet, or sometimes a few feet deeper. And once you have that point of stratification located, the active mixer circulator needs to be set to focus on just the warmer top water epilimnium. That is key. With a top water epilimnetic setting, long distance circulation can be achieved, which has been shown to mitigate cyanobacteria and associated cyanotoxins. It can also mitigate taste and odor issues for drinking water applications. It improves fisheries, and it improves overall water quality. If the lake is a source water reservoir, epilimnetic circulation can also help to create a more even and consistent water quality entering the treatment plant, which can be easier to treat. Now, on the other side of things, for deeper lakes, an active mixer circulator can also be set to circulate only the bottom water, known as the hypolimnium. Sometimes people refer to it as hypolimnetic withdrawal. This type of circulation does not try to break stratification at all. Rather, it is constantly introducing oxygen-poor bottom water with oxygen-rich top water, which can help maintain sufficiently high oxidation reduction potentials to prevent soluble manganese, iron, phosphorus, and hydrogen sulfides from diffusing into waters above the treatment plant intake. Hypolimnetic circulation can also reduce or eliminate temporary manganese spikes at fall turnover, and it also reduces the potential for fish kills. Okay, so to end this presentation, let's take a look at some equipment considerations that you should take into account should you ever want to introduce active mixing as part of your water treatment strategy. Earlier, we had talked about short circuiting in reservoirs. Well, there's another type of short circuiting that is often not talked about, and that is equipment short circuiting. Just like reservoirs, equipment can be prone to its own form of short circuiting too. Just because a piece of equipment moves water doesn't mean it's a good mixer. Some mixer designs can have a small area of influence and are prone to feed itself the same water over and over and over again. This really minimizes any sort of meaningful mixing impact. So when considering equipment for mixing purposes, it is helpful to again answer two questions. Is the inflow to the mixer directed? Meaning, does the flow enter at a specific part of the mixer? And is the outflow of the mixer directed? Meaning, does the flow exit at a specific part of the mixer too? If the answer is no, then the mixer might be prone to short circuiting. Whereas if both answers are yes, then the mixer is likely not prone to short circuiting. We can also apply the same two short circuiting questions we just used to determine whether or not a true direct flow rate can be calculated. If any answer is no, then a true calculated flow rate cannot be easily determined. And in these scenarios, more complex and often more subjective methods, such as computer modeling, are needed to estimate direct flow rates. If both answers are yes, then direct flow and velocities can easily be calculated. Okay, a couple quick last equipment considerations before we wrap this up. Mixer turbulence is not always a good indication of efficient mixing. Excessive turbulence can usually mean that there's a lot of wasted energy happening. Another thing to consider is that mixing is not instantaneous. Active mixing equipment needs to be sized properly and correctly for the flow attributes of the reservoir and for the desired mixing outcomes. It is extremely important that a good evaluation takes place. And one last thing, one very important thing, is that make sure the equipment manufacturer has your back. Make sure they have service capability and make sure they're going to be with you for the long haul. Working with a good company with good equipment is going to save you a lot of headaches in the future. All right, that's it. We're all done. If there's one thing we hope you walk away with, it's that active mixing is a very powerful water quality improvement tool that can help you make your water and treatment processes better no matter where you work in the water circle. So with that, thank you for your time, and I hope you have a great rest of your day. Thanks for watching.